So today we're going to be covering some other angle relationships, and one of the things that you'll notice, we'll work towards a problem on the end where we're dealing with the Earth. But a lot of these topics that we cover, we use for measurement, and a lot of the reasons we use them are for times when we can only use indirect measurement. Right? We can't take a tape measure out and measure the Earth or something like that. It's too big. So we need indirect ways to use the measurements we can take and then figure out bigger problems based on that. And so a lot of these things start with these basic principles like this. So, first, if a tangent and a chord intersect at some point in the circle, then the measure of each angle formed is half the measure of the intercepted arc. What that means is you have this tangent A, right? And I have this chord BA, and each of these angles, 2 and 1, are just half the measure of the intercepted arc. So let's take the example of 2. I know that 2 is half the measure of arc BCA. So whatever that arc is, angle 2 is half of that measure. Okay? So let's apply that right here. So we have angle 1, right? They're saying find angle 1. Well, I know that the measure of angle 1 is half of 210 degrees. And half of 210 degrees is 105 degrees. So that one's pretty straightforward. Let's see if the other ones are equally straightforward. We'll get a better pen color as well. Okay. The arc RST. So notice in this case they're asking me to find arc RST. Well, I know that 98 degrees in this case is equal to 1/2 measure of arc RST, right? I'm applying that same idea. So if half of that is 98, well then I know the measure of, if I just multiply by 2, I'll get measure of RST, arc RST is 196. And all I do is multiply the 98 by 2, because that would give you the intercepted arc. Okay, same, XY, they want to know what is arc XY. Same idea, it has to be twice the angle that's formed by the tangent there, so it has to be 160 degrees. So the arc measure is 160 degrees because the angle formed by the tangent and the secant there is 80. Next, it's going to matter where, if you have lines intersecting in a circle and we want to measure those angles, the measurement's going to depend on where the intersection happens. So obviously you could have the intersection right on the circle. But the ones we're going to focus on are if it's inside or if it's outside. And depending on where that intersection happens, it's going to change how we're going to find the measures of these angles. For instance, 1 or 2 or angle 3 right there. And again, so you got to focus, where is it? Is it inside the circle or outside the circle? And that's going to change the way we're going to find the measure of that angle. So if it's inside the circle, then the measure is going to be half of the sum of the intercepted arc. So if we wanted to find the measure of angle 1, its intercepted arcs are A, B, and D, C, okay? And we would add them up. We would take the sum, and we would take half. However, if angle 1 is outside, like down here, if we're outside the circle, we're still looking at the intercepted arc. So notice when I say intercepted arcs, what I mean is to form the angle, we have that secant, and we have that tangent. And those lines, as they move through, cut the angle here at AC. That's an intercepted arc of the circle. And they also do that at BC. So that is the other intercepted arc. And so if the angle's outside of the circle like it is here, if the intersection of those lines is outside the circle like it is there, then what we're actually going to do is take the difference of those intercepted arcs and take half. So again, if the angle's inside the circle, you're going to add up the intercepted arcs and take half. If it's outside, you're going to take the difference and you'll take half of that to find the measure of that angle. So let's apply that here. So we need to find y, and I don't know, they didn't give me that right there yet. So, but I can figure that out because I know if this is 102, then I know that that's 102. And again, that color is not very good. Then I know that that's 102 because they're vertical angles. And so I know that this and this right here are supplementary. So if that's 102, then this has to be 78, right? Because they have to add up to 180, and that's 78. Okay, so now I have an intersection inside a circle, and if I want to find the measure of one of my arcs, right, I know that that angle inside, I know that 78, and I don't know what happened there, I know that 78 is half of the sum of my intercepted arcs. And the one is measures y, and the other is 95. Again, I'm adding them up because my intersection is inside the circle. So I know that 78 equals 1/2, so just 78 equals 1/2 y plus half of 95. What's that? 47.5. 47.5. Subtract 47.5 from both sides. 78 minus 47.5. 30.5 equals 1/2 y. Multiply by 2, and we get 61 degrees is the measure of y. Okay, next. Number 2. This one's simpler because we don't have to figure out any angles right away. I know that my intersection is outside the circle. So I know that 30 is half of the difference of the intercepted arcs. So if I take A and I subtract 44, right, I know that 30 is half of that. So I'm going to have 30 equals 1/2 A minus half of 44 is 22. Add 22 to both sides. You get 52 is half of A, multiply by 2, and you get A equals 104 degrees. You actually, for 6, you want to think of something we learned earlier when we did the tangents and the cosines and the sines. And you'll see in a second why, because what they give us is we have this tangent. And we know that a tangent meets a radius at a right angle. So we have this right angle. So if we connect the dots here, we have a right triangle. Okay, so you should start thinking right away. Pythagorean theorem, trig ratios, tan, cosine, sine, anything like that. Right, so what do we know about the triangle? Well, we know that this little piece here is 2. But we also know that the radius of the circle is 3, and this is also a radius, so that's 3. Right, so that whole side is actually going to be 5. If you remember your Pythagorean triple, you could know that this side's 4. But even if you don't remember that, you could solve it by using the Pythagorean theorem. And even if you don't, it's still okay. Okay? But I'm going to take that triangle, and I'm going to draw it down here. I'm going to work with it down here. Right? That's my right angle. And the reason I'm going to work with this triangle is because what I really want to figure out is, what is this arc? Because I know if I figure that arc, then I know this arc too, because these are the same triangles, so that arc's going to be the same. And if I can figure out what this arc is, this whole arc, then I can back into what x degrees is, because I know that it's just what's left, right, once I figure out those arcs. And the other thing is, I know that this angle right here, this central angle, it's going to have the same measure as this arc. So if I can find the central angle here, I can find the measure of that arc, because central angles and their intercepting arcs have the same measure. And then once I do that, again, I can back into x. So what I need to do on my triangle down here is I need to figure out what that angle is, and I'm just going to call that y degrees. So now let's label what I know. I know that I have the hypotenuse of my triangle is 5. I know that that side's 3. Again, I know the other side's 4 just because I remember my Pythagorean triples, but even if you don't, that's okay. Because how do we find the angle of a right triangle if we have 2 sides? Well, we just think, I have my adjacent side and my hypotenuse, so that calls for cosine. So I know that the cosine of y degrees is the adjacent over the hypotenuse, but I actually want the angle. So I need to work backwards to the angle, so I'm going to use the inverse cosine. Inverse cosine of 3/5 will give me y degrees. So I'm just going to do that on my calculator. I'm going to do inverse cosine, 3 divided by 5, and I get 53.1. So y is 53.1 degrees. So now that means that this angle right here, and it's getting a little messy, but that little angle right there is 53.1 degrees. But this one is also 53.1, right? So this whole thing is 53.1 times 2 is 106.2. It's a little more than that if I round, but it's about 106.2. And which means this whole thing is about 106.2. So what's left? What's x? Well, it's just what's left of the circle. So if I take 360 minus the 106.2, again, I'm approximating, but we're going to get 360 minus 106.2, and you get about 253.8 degrees. It's a little bit tricky, but we're going to use that idea again in the next problem, and we're going to see how we can actually apply this to figuring out more interesting things, and why do we need to know this? So the northern lights are bright flashes of colored light between 50 and 200 miles above Earth. Suppose a flash occurs 150 miles above Earth, and that's why this line is 4,150, where the radius is 4,000, because they're adding that 150 right here, because the light is 150 miles above Earth when it flashes. Okay, so what is the measure of arc BD? Again, they're trying to get you to figure this out. What's this whole arc here, which is made up of those two halves? And you should start to see this is very similar to the problem we just did. Right, so what's the measure of that arc? And that's the portion of the Earth where that flash is visible. So we're trying to figure out something that we could never measure with the tape measure or something like that, right? But let's see if we can use that tool that we just did to do that. So what I know is this. If I can figure out that central angle right there, I'll change the color. If I can figure out that central angle, I can figure out that arc. And if I can do that, then I can just double it and I can get that, both of them, and I can figure out right there what arc BD is. So I'm just going to call, like I'm just looking at this angle right here. Find a good color for this. That angle is what I'm trying to figure out, right? The angle BAC. I just want to figure that out. Okay, so now I know that I have this right triangle because I know that any tangent to Earth meets a radius at a right angle. So I'm going to just kind of take that triangle down and I'm going to draw what I know about that triangle. And I know that the hypotenuse is 4,150. I know that's my right angle right there. I know that this side, the radius is 4,000, so that's 4,000. And what I'm trying to figure out is what is this angle? Well, that angle, if I'm looking at that angle, what I have is the adjacent side and the hypotenuse. So again, I'm using cosine. And so I know the cosine, and we'll make it, BAC. So I know the cosine of angle BAC is the adjacent 4,000 over the hypotenuse 4,150. But I don't want, what I want is the angle. So I need to work backwards. So again, I'm going to use the inverse cosine, and I'll do the ratio 4,000 or 4,150. Will give me the angle BAC. So I'm just going to plug that in. 4,000 divided by 4,150, and I take the inverse cosine of that amount, and I get angle BAC is 15.5 degrees. And again, that's only this side. So I just need to double that. So if I just do times 2, I get about 31 degrees. And that is that. So BD is about 31 degrees. So if you're standing on that 31 degrees of Earth's surface, you should be able to see the northern lights. And if you're not, then you won't be able to, because you'll be beyond the horizon.